Hello, fam. This is Zekaya from Mathatainment, reminding you that enthusiasm implies excellence. We are building from our first lesson where we were factorizing quadratic expressions, and now what we are about to do will be solving quadratic equations. The difference between a quadratic expression and a quadratic equation is that an equation is actually characterized by an equal sign. So let us define what a quadratic equation is. A quadratic equation is defined as follows. It is an equation of the form ax squared plus bx plus c equal to 0, where a, b, and c are all real numbers, and a is different from 0 to make sure that this is a quadratic equation. Hence, the highest power of x is 2. Otherwise, if a is equal to 0, then the coefficient of x squared will be 0, and then the term containing x squared will eventually disappear, and you'll be left with a linear equation instead of a quadratic equation. So that is the importance of confirming that a is indeed different from 0. This means we have a quadratic equation. So I'll just be straightforward here. A routine towards solving quadratic equations is as follows. First, we write our equation in the standard form, which is ax squared plus bx plus c equal to 0. That is our standard form. And then we incorporate the first lesson where we factorize the expression on the left-hand side of our standard form. We do this by employing either a common factor or the trial and error method, which we learned about in the previous lesson. And once we have factorized the expression on the left-hand side of our equation, then we know that our expression is actually equal to 0 if and only if at least one of the factors is equal to 0. We know that ax squared plus bx plus c is equal to 0 if and only if at least one of the factors is equal to 0. It means it's either the first factor is equal to 0 or the second factor is equal to 0, or both of them can be equal to 0. That's what it means when I say at least one of the factors is equal to 0. So let us do an example. You may notice from these examples that I actually used the very same expressions which we used in our previous lesson. And I'm using the very same expressions. I'm just equating them to 0 to make them to become quadratic equations now. So if you look at this one, the first example here, it's already in standard form because the value of a there is 3, the value of b is -4, and the value of c is actually 0. So it's already in standard form, but it's a binomial. So when we factorize the left-hand side, we want to employ a common factor there. So the common factor there is x. If I'm taking out x as a common factor, what remains inside, I divide each term with the common factor that I took out. And then I have equal to 0 there. So it means I have x into 3x squared all over x. I'm left with 3x minus, and then 4x over x, that is 4, equal to 0. Now, I want to highlight this part. You see the part that I'm highlighting there. That's a factorized version of my equation there. This means that since the product x and 3x minus 4, that product is equal to 0, it means at least one of the factors must be equal to 0. This means that it's either x is equal to 0 or 3x minus 4 is equal to 0. So x is equal to 0, or here I can go further and solve for x, or x is equal to 4 divided by 3. So those are my two values of x. I'm going to underline them. It's either x is equal to 0 or x is equal to 4 over 3. The nice thing about solving for x, or solving for an unknown for that matter, is that you can confirm if your answers are correct or incorrect. How do you do that? I'm going to use my famous calculator. What we do there, what you want to do is that you want to substitute the answers that you got into your original equation and see if we are getting equal sides. For instance, when you substitute 0 on the left-hand side, it looks obvious that you're going to get a 0. Let's try and substitute now 4 over 3. Let's try and substitute 4 over 3. So we are going to have 3 times 4 over 3 all squared minus 4 into 4 over 3 and see if we are getting a 0. Aha, we are getting a 0. It means 4 over 3 is also correct. And if we were to substitute 0, still we would get a 0, meaning that 0 is also correct. Let's look at the second example. The second example is 3x squared minus 27 is equal to 0. We want to factorize the expression on the left-hand side of our equation. That expression is a binomial, hence we are going to employ the common factor. So the common factor there looks like it's 3. And what remains inside, we are going to have 3x squared divided by 3 minus 27 divided by 3 equal to 0. So now we have 3 into 3x squared over 3, that is the same as x squared, minus 27 over 3, we have 9, equal to 0. Well, we can still do something with that factor, which is x squared minus 9. That factor is called the difference of two squares. So we have 3 into x minus 3, x plus 3, equal to 9. Well, this is an equation, so we are allowed to divide on both sides by 3. We are allowed to divide on both sides by 3. So if we divide on both sides by 3, 3 gets cancelled on the left, and then on the right, we are left with a 0. On the left now, we are left with x minus 3, x plus 3. And like I said, on the right, we are left with a 0 because 0 divided by 3 is still 3. Now, you see that factorized version there. Since that product is equal to 0, it means that it's either x minus 3 is equal to 0 or x plus 3 is equal to 0. It means at least one of the factors must be equal to 0. X minus 3 is equal to 0 implies that x is equal to 3 or x is equal to negative 3. These are your two solutions here for x. These are your two solutions for x. I'm going to highlight them in pink since we may not be able to see our underline there. I'm going to highlight these solutions in pink. I'll use my highlighter and then I'm highlighting them in pink. Aha. Now they are clear. Those are our two solutions. Let's look at the next example. This example, we are also required to solve for x here. And the equation is x squared equal to 8 minus 2x. The first question that we want to ask ourselves Is that in standard form? It doesn't seem like, because if it's in standard form, then on the right hand side, we want to see 0. Let us make this to be in standard form then. We are going to have x squared plus 2x minus 8 equal to, now it's in standard form, where the value of a is 1, the value of b is 2, the value of c is negative 8. And if we want to factorize the expression on the left-hand side of that equation, it looks like that expression is a trinomial, hence we are going to employ the trial and error method to find our factors there. The factors for 1 is 1 and 1, because 1 is the coefficient of x squared, and the factors for 8, such that when I subtract them, they are going to give me 2. After I've multiplied them with the factors for 1, it looks like I need 4 and 2 there. But remember, it's a trial and error method. You could try 1 and 8 and confirm that it doesn't work, and then change your combination and make 4 and 2. The reason why I'm just using 4 and 2 right away is because I'm getting better at this, since I saw it on our previous lesson, so now I'm getting better at this. 1 times 4 is indeed 4. 1 times 2 is 2. And now, the sign that I'm going to highlight in green says that I need to subtract that product. 4 minus 2, I'm getting 2. So I'm collecting my factors. Now my factors are like this. 1 goes with 4 and 1 goes with 2. But remember that the factors on the left-hand side, you suffix them with x. So it means we have x going with 4 and we have x going with 2. That is equal to 0. Now, the sign that I highlighted in green there means that our factors have different signs. Now that you know that they have different signs, then the sign that I'm highlighting in pink says that the bigger number deserves that pink sign. And in this case, the pink sign is positive, hence 4 deserves the positive and 2 must be negative. Now, that factorized version, since that factorized version, that product is equal to 0, it means at least one of the factors must be equal to 0. That is, either x plus 4 is equal to 0 or x minus 2 is equal to 0. This implies that x is equal to negative 4 or x is equal to positive 2. So you can go ahead and satisfy yourself by substituting these solutions to our original equation and see if we are getting sides that are balanced. You can go ahead and satisfy yourself in that regard. But our solutions here, x equal to negative 4 or x equal to 2. Let's look at the next example. This one is 5x squared minus 6 equal to 13x. Is this in standard form? It doesn't look like it's in standard form. So let us put it in standard form. We have 5x squared minus 13x minus 6 equal to 0. Now it's in standard form. And if we want to factorize the part on the left-hand side, that expression there, it's a trinomial. Hence, we want to employ the trial and error method to factorize that. So the factors of 5 is 5 and 1. The factors of 6, I want to use 2 and 3 in that order, 2 and 3 instead of 3 and 2. But I want to use 2 and 3, 2 above, 3 below. So that's when I say 1 times 2, I'm getting 1. 5 times 3, I'm getting a 15. And the sign that I'm about to highlight in green there says that I need to subtract that product, and as you can see that it drops down to 13 regardless of the sign, but it's dropped down to the middle term. Now, it means that when I'm collecting my factors, this is what I have. 5 goes with 2 and 1 goes with 3. So I have 5x because the factors on the left, you suffix them with x. 5x goes with 2 and x goes with 3 equal to 0. The sign that I highlighted in green says that the signs between my factors are different. Now that you know that they are different, the sign that I'm highlighting in pink says that the bigger number deserves that pink sign. In this case, the pink sign is negative. Now, the question is, who is bigger, 3 and 2 over 5? Remember why I'm saying 2 over 5 is because if you were to find a solution there, your x there would be 2 over 5, not just 2, but 2 over 5. So you're comparing 3 and 2 over 5. And apparently, 3 is bigger than 2 over 5. So 3 deserves the negative, and 2 there, or 2 over 5, deserves the positive. Therefore, it's either 5x plus 2 equal to 0 or x minus 3 equal to 0. This means that x is equal to negative 2 over 5 or x is equal to positive 3. These are your solutions. Again, these are your solutions. You can satisfy yourself by substituting them into the original equation and see if you are getting balanced sides. Right. Okay. Some of the questions, they may not come in handy as you may have expected, so they will need you guys to employ your brains a little bit. For instance, look at this one. It says solve for x, and the equation is 3x to exponent 2 over 3 minus 13x to exponent 1 over 3 minus 10 equal to 0. Aha. What is happening here? What I'm seeing here, I'm seeing x to exponent 1 over 3 squared. And I see x to exponent 1 over 3 to exponent 1. And then I see a constant which is 10. By that, I mean, this is what I'm saying. I can write this equation above as follows. I can write 3 x to exponent 1 over 3 all to exponent 2 minus 13 x to exponent 1 over 3 minus 10 equal to 0. Apparently, that is still a quadratic equation, but not in terms of x, but it is in terms of x to exponent 1 over 3. That's why it's essential to let k or any other variable to be equal to x to exponent 1 over 3. Let k to be equal to x to exponent 1 over 3. So I'm going to highlight this. Let k to be equal to x to exponent 1 over 3. Then your equation now looks like this. You have 3k squared minus 13k minus 10 equal to 0. That's a quadratic equation now in terms of k. And if you want to factorize the left-hand side, it is a trinomial, that expression. So you want to employ the trial and error method. The factors of 3 are 3 and 1. And the factors of 10, you may want to think about the factors of 10. The factors of 10, you may think of 5 and 2 in that order. So that when you say 1 times 2, we are getting 2. 3 times 5, we are getting 15. And then the sign that I'm highlighting in green there, the sign that I'm highlighting in green says that you have to subtract that product, and you can see that it drops down to 13 regardless of the sign of 13. So now when we are collecting your factors goes like this. 3 goes with 2 and 1 goes with 5. Aha. So now I'm going to have 3k, because I'm suffixing the factors on the left with k. 3k goes with 2 and k goes with 5 equal to 0. The sign highlighted in green says that the signs between my factors are different. Now that you know that they are different, it's about time you go and highlight that one in pink. It says that the bigger number deserves that sign. Who is bigger, 5 and 2 over 3? And definitely 5 is bigger. So 5 deserves the negative and the other one is positive. This means that k is equal to negative 2 over 3, or k is equal to positive 5. However, you are not solving for k here, but you are solving for x. So now remember that I want to change the color for this. Remember that this means that your x to exponent 1 over 3 is equal to negative 2 over 3, or your x to exponent 1 over 3 is equal to 5. That's what you have. So this means that if I take the cube on both sides, if I exponentiate on both sides by 3, then this is what I'm going to have. I will have x on the left hand side being equal to negative 2 over 3 cubed, or x being equal to 5 cubed. So what is negative 2 over 3 cubed? That is exactly negative 8 over 27. That is negative 8 over 27. That's your first answer. Or x equal to 5 cubed. 5 cubed is exactly 125. So these are your two solutions now. We have solved for x. So the emphasis is that you shouldn't end at k there. You should remember you said k is equal to x to exponent 1 over 3. So you shouldn't end at k there. These are your two solutions. We have x equal to negative 8 over 27, or x equal to 125. So now, let us do another example here. This one says, and this one is, it has two portions here. The first one says, solve for x if the square root of x minus 2 is equal to 2 minus x. To solve for x there, we want to get rid of the square root there. So it means we want to square both sides. So the square root of x minus 2 all squared is equal to 2 minus x all squared. That's what it means to square both sides. So now, x minus 2 is now free on the left-hand side, equal to, expanding that, I can write it as follows. It's the same, 2 squared is 4, and 2 times negative x, that is negative 2x, times 2, that is minus 4x. And then negative x all squared, that is plus x squared. This is the same as writing those brackets twice as a product, and then you remove the brackets carefully. You will eventually arrive at this step eventually. Right, now let us transpose everything. Let us transpose everything to the right. If we transpose everything to the right, we are going to have x squared, it's already on the right hand side, minus 4x is already on the right hand side, plus 4 is already on the right hand side, and now negative x because it's coming from the left to the right, and we have plus 2 because it's coming from the left to the right, equal to 0. That's what we have over there. And then now we are going to have x squared minus 4x minus x, that is minus 5x. 4 plus 2, that is plus 6, equal to 0. Now we have reached our standard form there. And the expression on the left is a trinomial, as you can see. We want to employ the factors. So the assumption is that you know how to do the trial and error method. So I'll just write the factors right away. Equal to 0. So the factors are x goes with, let me see, x goes with 2, and another x should go with 3. Yes. And you see the sign that I'm about to highlight in green there? It says that the signs are the same since that sign is positive. And now that you know that they are the same, the sign that I'm about to highlight in pink there says that, okay, fine, the signs are the same. How are they? They are both negative. That's what that sign tells you. So they are both negative. This means that x is equal to 2 or x is equal to 3. Those are your answers. X is equal to 2 or x is equal to 3. Those are your solutions. Now, the second question, question B says, hence solve for P if square root of p squared minus p minus 2 is equal to 2 plus p minus p squared? Well, this invites the use of our brains. This motivates the use of our brains. For instance, when you see a question with the word hands, it means you are likely to use what we have found above. It means you are likely to use what we have found above. So for example, I want to relate this equation that we are given here to the one that we found above. So look at this one. I have a square root, and underneath the square root, underneath this square root, I'm going to have p squared minus p minus 2 equal to 2 minus, okay, now I want to write p squared minus p, because I took out the minus 1 as the common factor there, then I have p squared minus p. You see that here, if I'm highlighting this part here, I'm highlighting p squared minus p squared minus p. It looks like if I treat p squared minus p as x, that equation looks exactly as the equation that I was given in A, and where I found x to be equal to 2 or x to be equal to 3. So this means that here, this implies that you can just go ahead and say p squared minus p is equal to 2, or p squared minus p is equal to 3. Then you solve for p from here. You solve for p from here. Now you are going to have p squared minus p minus 2 equal to 0, or p squared minus p minus 3 equal to 0. So you want to solve for p on both these equations. Now, having used the word hence, it means you are able to use what we have found above. And you can see that on the first option, we have a trinomial there. So to factorize it, you definitely need to use the trial and error method. On the second one, you also have a trinomial. To factorize it again, you also need to use the trial and error method. So I won't even finish this one. I just wanted to emphasize that some of the questions, they require us to use our brains beyond what we have learned in class in order for us to interpret it using what we have learned in class. But the question itself, it doesn't necessarily come in handy to be exactly what we learned in class. Yeah. Okay, so this is how we end our lesson, but I'm not leaving you guys alone. I'm leaving you guys with your problems to try. So this is yours to try. Solve for x on each of the following equations here. You have x squared plus 6x equal to 0. We have 4x squared minus 16 equal to 0. We have 4 to exponent x minus 6 times 2 to exponent x equal to 16. And we have square root of 2x plus 5 minus 3 over square root of 2x plus 5 equal to 2. Yes, so please solve for x there. And trust me, all those equations, they satisfy the definition of being quadratic equations. So none of them should look scary to you. You just have to find a skill of manipulating them to look like quadratic equations. Thank you, guys. We are going to meet again on our next lesson. And on the next lesson, we will be solving quadratic equations using what we call completing the square method. That's what we'll be using on our next lesson. You are on Math Attainment. Thank you. We'll meet again on the next lesson.